Assalamualaikum and hi everyone. Let's continue with topic 6 on object and class. In this topic, we will learn about object, what it is and how to use it. In the first part, we will cover about creating an object and a method. In the next parts, we will learn about user-defined methods, which are methods that we will create. It covers the syntax and other details on writing our own method. And finally, the concept of method overloading. What is an object? An object represents an entity in the real world that can be distinctly identified. For example, student, book, desk, and course can be an object. An object has a unique identity. It contains the state, which is the data fields or properties of an object. State is also called as the attributes. An object also has behavior, which is defined by a set of methods. Invoking a method on an object means that asking the object to perform a task. In simple words, an object can do things and can have things done. Behavior is also called as procedures, methods, or operators. An example of a method that we have seen so far is the main method. Based on this explanation, what is the difference of an object and a class? A class is a template or blueprint from which objects are created. An object is an instance of a class. To use an object in a program, we need to first declare and create an object. The first step in using an object is to declare it. An object declaration has the name of an object and the class to which the object belongs to. For example, we have here customer, my customer. In this declaration, we are declaring the name my customer, which we will use to refer to a customer object. Customer is a class name where the class must be defined before it can be used. My customer is the object name when we want to declare an object. Any valid identifier that is not a reserved word can be used as an object name. An identifier is a sequence of letters, digits, and the $sign, with the first one being a letter. We use an identifier to name a class, object, methods, and others. No spaces are allowed in an identifier. Remember that upper and lowercase letters are distinguished in Java. We have learned about identifiers in the previous topic. Let's look at an example of object declaration. Here we have a class called customer. Within the main method, we declare two objects of customer where we called as my customer and new customer. This is how we can do object declaration. At this point, it doesn't do anything yet, but later on we will see why do we need to create objects. An object declaration simply declares the name, which is an identifier, which we use to refer to an object. The declaration does not create an object. To create the actual object, we need to invoke the new operation. We have seen some examples of creating object when we learned about scanner object. As I have mentioned before, when we do scanner input equal to new scanner system.in, we are creating an object of scanner that we call as input. This is the same as that. In the previous slide, we have declared the object by writing customer, my customer. Now we can use the object name straight away. To create an object, we need to write new and followed by the constructor, which is creating an instance of the customer class. We will write the brackets with nothing in it as there are no arguments to be included. We will learn on how to write the constructors later on. A constructor is basically a method that has the same name as the class. It executes automatically when a new object or instance of that class is created. The default constructor has no parameters or argument as shown in this example. An example of constructor with arguments is John equal to new student John Java. This is a constructor that takes in an input. It needs to be written by a programmer. The no-argument constructor by default is created by Java. Make sure that you understand the distinction between object declaration and object creation. The concept is similar to when we declare a variable and initializing it later on, only that we are now dealing with objects. Going back to the example code that we have from before, here it shows we can have the object declaration and object creation in 2 lines. We have customer my customer, then my customer equal to new customer, which is creating the object. We can also declare and create the object straight away. For example, customer new customer equal to new customer. When we write my customer equal to new customer, that customer is the constructor of this class. That's why it has the same name as the class name. This slide shows the distinction between object declaration and creation by showing the effect of executing the 2 statements in the memory allocation. Notice that the memory space for a customer object does not happen until the correct new command is executed. So, when we declare the object by writing customer my customer, the space is allocated in the memory. When we write my customer equal to new customer, it finds new, so it creates an object and the identifier my customer is set to refer to it. Here are 2 different diagrams showing the same information. Namely, there's a customer object and the name we are using to refer to it is my customer. Say that we have this code, customer my customer equal to new customer, and on the next line we have my customer equal to new customer again. Is this code fragment valid? This is valid, and the name and the object itself are 2 different things. The same name can refer to different objects at different times when the program is running. This example shows the same name pointing to 2 different objects at different times. The same name in this example here is my customer. It cannot point at 2 different objects at once. Let's look at what happens in this code. So when we declare the object by writing customer my customer, it first allocates the space in the memory. When we write my customer equal to new customer, an object is created. If we create another object using the same object declaration, we can do it. So we can write my customer equal to new customer again as highlighted here. Since there is no reference to the first customer object when the second new statement, it will eventually be erased and returned to the system. Remember that when an object is created, a certain amount of memory space is allocated for storing this object. If this allocated but unused space is not returned to the system for other users, the space gets wasted. This returning of space to the system is called deallocation, and the mechanism to deallocate unused space is called garbage collection. In this case here, we will not be able to refer to the first object anymore as we have created a new object and assigned it to my customer. Now we know how to declare and create an object. After an object is created, its data can be accessed and its methods invoked using the dot operator. For example, by writing object reference variable .data field to access the data field in the object. And to invoke a method, we can write object reference variable .method, which depends on what type of method we are invoking. Here we have my customer, which is the object name, .setCustomerInfo, where setCustomerInfo is the method name and the method takes in one argument of type string. As the method is something that we write, it can be called anything and it depends on us whether to have one or more arguments of whatever types. The name of the message we send to an object or a class must be the same as the method's name, so we use the phrase calling an object's methods and sending a message to an object interchangeably. This code here shows an example of the more complete code of class customer, where we have a method called setCustomerInfo that takes in a string. To make it simple, in this method, what it will do is displaying the string value that is being passed to it. In the main method, we declare and create an object called myCustomer. We use the dot operator to call the method setCustomerInfo and passing the string Ali. If we run this code, it will display Ali on the screen. Here is showing another example. See that we have an object called car and it invokes the printColor method, where printColor method does not have any argument. If we want to access the data of a variable, we still need to use the dot operator and the data field. For example, car.color. Let's look at the code of a class called vehicle to make sense of this. Here we have a class called vehicle. We then have a global variable called color that is of type string. It has the value red. Then we have the main method. We also have another method that is called printColor. Methods can be written anywhere within the class. Here I wrote printColor method at the bottom of the code. I can write it before the main method. It does not matter. In the printColor method, it has a print statement, so it will display the sentence car color is when the method is invoked. Within the main method, we declare and create an object of vehicle class called car. It then called the printColor method by writing car.printColor. At this point, it will display the sentence car color is. On the next line, we have system.out.println, and within it we wrote car.color. So the object car is referencing to the variable color, which has the value red. Car.color will have the value red. So the final output of this code is car color is red. Try and run this code to ensure that you understand about object and using it to call the data field or variable and also to invoke the method. This is the template that we use when writing our class. We are familiar with this as we have been writing our own classes. We can write the input statements at the very top, then the class name, data members, which are the variables, and then the methods. We will learn about methods later on. Why do we need to declare and create an object when we can simply call it as what we have done before? Let's look back at this example. In the purple box, we can call printColor method and color variable without creating any object. So basically, if we are within the same class, we do not actually need to create an object as we can access the data field and methods straight away. It's different if you have methods in different classes, so you need to create the object of the class that you try to access. Let's modify this code and separate them into two classes. So here we have two classes. The first one is called vehicle that has a data field color and a method called printColor. Another class is called vehicle task that only has the main method. Within the main method, it creates an object of class vehicle to be able to access printColor method and color variable from the vehicle. The advantage of separating into different classes is, say that we have another class called car. We do not need to modify the existing classes as car is able to access vehicle class method data field and add its own method and data field. Try and run these classes to make sure that you understand what each of the classes do. Data members are the variables that the class or methods have. The syntax for it is modifier, data type, then the name. For example, private string owner name. The modifier private means that this variable called owner name can only be accessed within this class. What we have been using so far is without specifically writing the modifier. When we don't write anything, it means that the modifier used is the default modifier. It can be accessed within the same class and also from different classes. We will learn more about the access modifiers later on. Let's look at methods declaration. A method declaration consists of a method header and a method body. In the header, it has the modifier, return type, method name, and the parameters. It then needs the braces, both opening and closing, and within it is the statements. Here is an example of a method declaration. Public void set owner name string name. The modifier is public, meaning that any classes and packages can access it. The return type is void, which means this method does not return anything to the statement that calls it. We can have methods that return an int, double, string, or any other type. Then we have the parameter, meaning that this method takes in one argument of type string. Within the method's body, we can have other statements. For example here, owner name equal to name. Say that we have this code. Let's go through it line by line to understand what's happening. Here we have a class called owner. The data member of this class is private string owner name. In this class, we have three methods called setOwnerName, getOwnerName, and the main method. In setOwnerName method, the modifier is public. The return type is void, meaning that it does not return anything to the caller. It has one argument of type string that is called name. In the method body, it takes in the name and keep it within the variable called ownerName, which is accessible by any methods within the owner class. The next method that we have is called getOwnerName. The modifier is public, and here it has a return type string. This means in this method, it will pass back to the caller a string value. In this example, it will return the uppercase value of the owner name. We have seen and used two uppercase methods that is from the string class. In the main method, we declare and create an object of owner class called the owner. We ask the user to enter the owner's name and we keep the value of the variable called owner name. So owner name has the value p_rumly. We then call the setOwnerName and passing it the value p_rumly that the user has entered. From that line, it invokes the setOwnerName method and pass the value to variable ownerName. So ownerName now has the value of name, which is p_rumly. Going back to the line within the main method, we want to call getOwnerName method and keep the value that the method returns into a variable called display. The getOwnerName changes the ownerName variable value to all uppercase and returns it to variable display within the main method. So, when it gets to the last system.out.print, it will display owner's name is and the name of the owner in capital letters, which is p_rumly, as shown in the output over here. It makes more sense to declare and create an object when we have at least two classes. Let's change the code before into two classes. Here we have owner class and owner test class. Owner test class only has a main method. For owner test, to access the owner's class methods and data field, it needs to create an object of owner. It can then access and invoke the methods and data field of the owner. Let's look at another example. Here we have a class with a method called max. Let's look at the method's header first. The method's modifier is public and it has the return type int. It also has two arguments or parameters which are in type int as well. In the method's body, we have a variable called result of type int. It then has if-else statements. Because in the method header, we wrote that the return type is int, we have to write return result at the last line in the method body. It doesn't have to be the variable result, it can be anything. For example, return 1, 2, 3, 4, 5, 6. That is valid. If we write like that, that means that it will pass the value 1, 2, 3, 4, 5, 6 back to the caller. We will see some example output later on. To invoke the max method, as it returns an int value, we can use a variable when calling it. For example, int z equal to max xy, where x and y are int values. They need to be int because in the method header of method max, we define that the method takes in two int parameters. To make sense of it, we can write max 10, 3, where those are the int values. We can enter the numbers straight away or through variables. When we write int z equal to max xy, this line means whatever the result from max method will be kept in the z variable. So, return result means it will pass the value of result back to variable z. Here is showing the complete code for the example from before. We have the main method where it is where the max method is invoked. If we run this code, it will ask the user to enter two numbers. Say that the user enters 10 and 3. 10 is the value for variable x and 3 is the value for variable y. When it calls the max method, in the method x is called as num1 and y is called as num2. They use different variable names, but they refer to the same values. You can always write your method header as public static int max, int x, int y. That works fine as well. It doesn't matter what you named your variable as. At the end of max method, the return result will pass the max value, either num1 or num2, back to variable z that invokes the method. So z will have the value of result. The if-else within the max method, it compares 10 and 3. So 10 is larger than 3. As that is true, result is equal to 10. Return result is basically returning the value 10. So variable z in the main method will have the value of 10. When we do system.out.println, it will display that z has the value of 10. Try and run this code to check if you get the same output as shown here. Now, let's change, instead of return result, we will do return 1, 2, 3, 4, 5, 6. What do you think the output will be when we enter 10 and 3? Does it return 10? It returns 1, 2, 3, 4, 5, 6. This is because we return the value 1, 2, 3, 4, 5, 6 to variable z, regardless of the value of result, because we did not write return result. So the value of result is only known within the max method. So the value is not passed to any variable. This return is useful, say that you want to return a string with some values, for example, the result value and some sentences. See here that I changed the return type of max method as string. Then, at the return, I return the sentence with the value of num1, num2, and result. At the main method, I have string z, and at the last print line, I display the value of z, which is the sentence that is passed from the max method. When I run this code, we get the exact output as before, even though the code is slightly different. So from here, you can see that there are various ways that you can use to have the same output by using different return type and return values. To summarize, we have learned about object and method. We will revisit and learn more about method in the next part.